Welcome. We'll try to understand how we can apply Excel in the case of our statistical analysis. So there are various statistical tools like SPSS, Minitab, R, and Python is there, but still how Excel can also be applied for our statistical analysis that we'll look into in this video. So let us see how we can install this data. If you'll go data, then in the data you will get there is a called data analysis. So first of all you go click on data. So once you click on data, then in the data there is a called data analysis. If you are finding this data analysis is good, if you are not finding data analysis, please follow the method how to download this data analysis in your Excel. So go to the file. Once you go to the file, then can you see there are options? So click on options. So once you click on options, you now click on add-ins. So once you click on add-ins, then you click on go here, go. So once you click on go, then you click on this analysis toolpath. So along that, if you want to add all other, you can add them, or otherwise you can leave them. Like I do not want this. I am not putting. So once you tick on this, then you put OK. So if it is not there, it will take 1-2 minutes of time to get installed. Then once you click on the data, then afterward, then you can see this add-on data analysis and solver. So let us see one statistical analysis with this. So I want to do the analysis of the 20 audit time as a sample data. I have taken the audit time taken by the different auditors for an activity, and this 20 audit time is recorded here. So I want to do some analysis. If you will click on, once you install, then if you will click on the data analysis, then in the data analysis pack, can you see here so many things are inbuilt like ANOVA test, correlations, covariance, descriptive statistics, exponential smoothing, histogram. So let me do descriptive statistics. So the first and the basic thing that we can do in the statistics, the descriptive statistics. What do you mean by the descriptive statistics? It's all about the describing the data set that is there. To describing the data set may be of two types, that may be in the form of multimedia or the visual form like graphs and all histogram and all this pie chart, line chart, or it can also be in the form of your statistical analysis like you can have the mean, median, mode, then you can have standard deviation, you can have the correlation, you can have the range of the data, you can do some find out some outlier or the box plot. These are all the descriptive. You are describing the data in terms of the mean, median, mode, the maximum of the minimum of the data. So we want to understand the data uh, description in terms of on an average, and the range of the data, and the median, the first quartile, second quartile, or the median, or the third quartile, or 75 percentile. So the first quartile is what about the 25 percentile, means the number below is 25% of your data is there. So 50 percentile is the median. 50 percentile means is the point or the data point below is 50% of your data are there. Third quartile is 75 percentile. That is not that the meaning of that, that below who is 75% of the number below is the 75% of the data is there in that data. So interquartile range is Q3 minus Q1, the 75 percentile data point minus the 25 percentile data point is the interquartile range. Range is equal to the maximum value of the data minus the minimum value of the data is known as the range. Similarly, the dispersion of the data you can measure through the variance. The variance calculation all of us know. The variance calculation all of us can do by like the data, you are subtracting the data from the mean of the data, then you are squaring it out, then you are finding out the summation square that will leads to the variance of the data. So the variance of the data, well, I'll show you the calculation. Let us do the descriptive statistics through the Excel first. So the descriptive statistics I want to do for this. So let us see. So input data range, what I want to take, the input data range, this is the all the audit time. You can take the audit time from the beginning. So like this you can take. And if you are taking the heading of the data point, then you have to put the labeling. So labels in the first row. So the first row will be considered as the label. If you are not taking labels, then you can take only the data points. So you took the column. Now you want to see the output range. So output, you want to see the output of the data analysis. Let us see, I want to have the data analysis here. So the summary statistics, if I'll do summary statistics like this, so it will give me the all summary statistics. So let us see what is going to. So first I select the data point here in the input range. Then I put the output where I want to see my output. In C6 cell, I want to see my output there. You want to see in a new worksheet, then you can click on this, or you want to see in the output range, you can click on. Then click on the summary statistics. So summary statistics, see the result now, how result you are getting. Can you see here in just single click what we could able to do? I can able to find out the mean of the data, the mean of the data, the standard error. I'll talk to you about the standard error of the data, but the median of the data. So the median of the data, can you find 18 is the median of the data, that is below 18, 50% of your data are below 18. If you'll do the sorting, then you can. Then sample variance is 29, and the kurtosis skewness is range of the data. Range of the data is 21. So minimum is 12, maximum is 33. So different to do an analysis of this data set. Again, I can go data, go to the data. So see the data point, but I want to do analysis of this data points. So what I'll do, I can take the data points. I can put, so I don't know how many data are there. So the column, the output range, I want to have the output here. Wherever I want, let me click here. So I click the output here, and so after clicking the output, yeah, you want to see the result here. You want to see in a new worksheet, then you can click here. But if you want to see the new worksheet in the same Excel sheet, you can click here. But if you want to see in the desired this point, then let us see the. So I got this count is 50 data. Can you see this is the 50 data, total sum of the data, and this is the data maximum 141, data minimum, range of the data, and then we can see the median and mode. So suppose there are millions of data and we do not know what is the max and minimum. There may be so many data and we do not know. So just by clicking, by doing this small exercise, you can have the data, whole data analysis. On an average, the score, this is the CAT entrance test score, the test score out of the 150 max. So but the mean of the score we are finding 98.92. The standard error I'll explain. The median, 50% of the data are below 97.5 marks. So 97.5, the mode is the most repeated data, is the mode is the 92 here, and the standard deviation and the variance is here. The variance is nothing but it is the square of the standard deviation. And so all of us know how to calculate the variance of the standard deviation. So let me show you how to calculate the variance of the standard deviation. So x is the data. So this is the data point, suppose 2, 3, 4, 5, 7 and 8. So let us see the okay. So let us see the mean of the data. The mean of the data is equal to the average. So average of the data is the mean of the data. This is the mean. So we are finding the average is equal to 5. The average is equal to 5, and all of us know x minus x bar that I want to calculate. So x bar is nothing but, so this number is the x bar. Let me take, so the average is also known as the x bar. So this is x bar. Now let us find out the 2 minus x bar. So this is the x bar. So x bar is the mean of the data is known as the x bar. So let us put the dollar symbol here. You can put dollar symbols, put dollar symbol, click here and put dollar symbol so that I can keep it fixed. Then let me do the calculation of all the, so I find out x minus, so here let me write down x bar is equal to the average of x. So here I found out. Now if I'll do the summation of this, sum of all the data from the mean will be equal to, here can you see, it will be always be 0. So some of the numbers are below the mean, they are negative. Those who are above the mean, they are positive. Sum of all of them are 0. So we are not finding how much data is dispersed. Suppose if I'll take all the data are 5, all the data are 5, so then also the mean will also be, suppose I take a data set y, so all the data is, the average of the data is, average of the data is equal to 5, and is equal to 5 the average, but also the y minus y bar here also is equal to, y minus y bar will also be equal to, if I'll do, it will be 0 all the time. So 5 minus this 5, and if I'll put dollar symbol here, put dollar, if I'll put dollar here, so it will remain fixed. So here invariably here also I'm getting 0, and here also sum of this will equal to, sum of these will also be equal to 0. So there is nothing to calculate. Sum of these will also be equal to what? 0 here. So once I understood the sum of the data here is 0. Now let me do some calculation for this sum of is equal to 0. Let the equal to sum of the data is equal to 0. Here also 0, here also 0. Then there is no point of finding out the dispersion of the data from the average point. So to get rid of this negativity, what I need to do? X minus x bar, then I need to do the square of it. So square of it will do the, that will take the, get rid of this. So this is a square. So if I'll do the square of it, so in this case the sum of the data is no more equal to 0. If I'll do the sum of this, so that is not equal to 0, that is 28. So the variance of the data is equal to 28. The average variance, what is the average variance? How many data are there? So how many data are there? Let me check. 1, 2. So if I'll drag, then I am finding there are, can you see, there are 7 data. So 28, what is the variance? The variance is equal to, the average variance is equal to 28 by 7, or So I found the variance is equal to, can you see here, I can write the variance is equal to 28 is the sum of all the value by 7. So that is equal to 4. So variance is nothing but, what is the variance? Variance is the sum square of all the data from the mean, then we are dividing it by the number. So we are getting 4. Then the standard deviation of the data will be equal to square root of variance. So square root of variance is equal to 2. Do you want to see the variance of the data in the, so let us check the variance of the data. The variance of the data you can calculate through this method. So the variance of the data is equal to, can you see the variance, population variance, and so this, if I'll do, the variance of the data is equal to, oh, variance of the data is equal to 12. So the variance of the data is not the variance of not this data set. The variance of this data set I want original. This data set I want to find. This data set is equal to, can you see it is 4. So the variance, this is known as the variance of the data set. Now the standard deviation of the data set, is the data set. I want to find out the standard deviation. This is equal to 2. Can you see the variance and standard deviation we calculate manually? We are getting 4 and 2 here, and the standard deviation and variance that I calculated here is also 4 and 2. So this is the way we get an, so you can now if you want to take if I'll do the data analysis, then also I can calculate directly the variance and standard deviation of the entire data set. But this is the population variance. This is about population variance. This is also population standard deviation. Huh? Now suppose I want to find out the variance, sample variance. So sample variance, what I have to do, sample variance, what I have to do, the sample variance is equal to, 22 by n minus 1. N is equal to 7, 7 minus 1 is equal to 6. So that is equal to sample variance. So sample standard deviation is equal to square root of the variance, SQRT. You can put so SQRT of this value is equal to 21. So now you want me to calculate the uh, sample variance from directly. If I'll calculate the sample variance directly, standard deviation, this is the sample standard deviation is, if I'll calculate through this is the data of x, so this is equal to 2 point, this is the sample standard deviation, sample standard deviation. Now you want sample variance is equal to, let us take variance s. So variance s of the data is equal to, can you see it is same as this variance. Points are, so if I want to take the label, I have to choose from here. I put label, so then I want to get it at n29. So let us see the result. Can you see the mean? Mean we got 5. Then we got the standard deviation. Can you see the standard deviation? The sample standard deviation 2 point. The sample variance we are getting 4.6. Then we are finding the minimum as 2, the maximum as 8, and the sum of them are 35, and the count is 7. So whatever we are calculating, the mean, the variance, the standard deviation, and mean, we can calculate directly through the data analysis. So that is the first step of our whole analysis. But if there are more than two set of data are there, if there are more than two set of data are there, so let us go to the data set where there are more than two data set. So in that case, how to do analysis? Let us see the data analysis part. So in this case, can you see here we are finding there are so I want to find percentage of spend on education and the unemployment rate. I want to find out. So these are the country in the world, and their population size, their computer sales, and the sales per capita, GNP, gross national product per head, unemployment rate in that country, and percentage of spend on the education, age, percentage of age they've spend on the education. So now this is the data set. Now suppose I want to find out the correlation of these two. So to find out the correlation between these two, so what I can do, now I can go to the data analysis. I can go, can you see here correlation? Go to the correlation. So correlation between these two I want to find out. What I'll do, so this my input data. So input data labels, because I'm taking heading, the output range I want to find out here. So can you see the output here? If you'll see, the output is minus. So unemployment rate and education are negatively related. Now I want to check the education versus the my this computer sales versus education, and I want to find out the correlation of all of them. So computer sales, sales per capita, then your GNP per head. So this is the way I want to find out the total. So the sales, GNP, unemployment rate, and education, how they are related. Because sales are there, sales per capita is given here. So I am not taking computer sales, I am taking sales per capita. So I want to find out correlation of these four together. So how to find out correlation of together when there are more than two headings? So go to the correlation and take the all the data point here, and click on where you want to find out the correlation. The correlation, suppose I want to find out here in this point. So here I want to find out, I can put OK. So can you see here the sales per capita is depend directly highly correlated 0.6 is to the GNP, the gross national product. That the if the higher the gross national product, people more buying power. But the sales per capita is negatively related with the unemployment rate. If they are unemployed, so the rate is high, then your sales is going down. And how much how much they are spending their, yeah, education, accordingly they are highly correlated with the sales. So this is the way. And unemployment, and you can see the here you can take the next item, this two. Can you see this is the correlation between GNP and the percentage. So higher is the your education, means higher is the GNP, higher is the education you are finding. So here can you see unemployment rate and the percentage? The unemployment is, if it is high, so then education is low. So they are negatively related. Percentage as they've spent in education and unemployment negatively. So this is the way you can find out the correlation among the data. So this is the way correlation we can find out. Correlation of the data set. All of you understood the correlation. Now let me find out the regression. I want to find out which factor is contributing most to the cells of this computer cells. So to find out, this is my dependent variable computer cells. I want to find out on the basis of the GNP. So let me find out how to do regression. I want to predict the sales of computer on the basis of gross national product, their region. So let me see. So this is, let me go about uh, the regression. So can you see regression here? The input range is the y. Y is my computer cells, is my dependent variable. The input x range is my independent variable. Y is always dependent, remember, my independent variable. So labels, I have taken the heading. So labels I am putting. The output range, I want to check the output here. So this is all about the simple linear regression. So simple linear regression here I can put here. Can you see the here the regression? So r square we are finding the interpretation of it. I'm not giving you now, but you just see this is the your equation. Your equation is 11 point this plus, if I'll do this plus this into your x. So this plus this into x is equal to my let me put this is this. So if I'll take a summation of this, so let me put the equation 11.30 plus 0.00277 into x, y is equal to, this is the regression equation. Understood? This is the simple regression. I this value into x1, that is GNP, for 4.84 into unemployment rate, 23.1 into and the percentage of spending. So this is the way this regression equation can be formed on the basis of this. Now I want to, so this is the way this we got simple regression and the multiple regression. Let us find, I want to test my perception that audit time is on an average is 20. So that is my perception. So I want to test. So I want to do the t-test, t-test, t-paired Z test for the two sample. So I want, suppose I want to take a samples from this data. So I want to take 30 sample from the, I want to take this is lovely random number of sample, yesterday we understood, and I want the sampling, suppose I want to choose the 7 data from this and I want to put it here. Can you see? So it gave me the 7 random data from the entire data set. So this is the sample audit data. Audit time. Now let us see the sample data from this correct. So from this data set, how many in the aptitude, how much correct are there? So I want to see the, so I want to do sampling. So in this case, I want to choose this whole set of data. I want to choose the data, and the number of data I want to choose from this 50 data is 10, and I want to see the output. The output of the data is here. I want to see the output of the okay. I've chosen the two different. I should choose only one heading. So this, can you see, we just choose. So similarly, suppose there are thousands of data and we want to take a sample of data. How to take the sample of data? Through the random sampling. This is the way you can take a sample of data from this entire data set for your analysis. So 10 data I picked from this entire 50 out of 50 data, and this data I can put the, so this is the sample of, this is the sample of the corrected data. This is the sample data. And the data.